Hi everyone, we're back here on the OCR specification in A-level chemistry, this time looking at paper 1 from 2019, and we have another level of response question here, and this one is about rates of reaction. We've got 3 different students here who have investigated the rate of reaction between bromine and propanone in the presence of hydrochloric acid. Each student investigates the effect of changing the concentration of one of the reactants whilst keeping the other concentrations constant. And what we've got here are 3 different kinds of data, and the instruction from the question that you can just see at the bottom now is to explain how the reaction orders can be determined from the student's results and determine the rate equation and the rate constant. Now, just before we get started with the full analysis, and I'll show you how I would lay this out in the exam, I'd just like to point out once again, OCR here have put several instructions here for this level of response question across just 1 or 2 lines in this case here. So please make sure that you do go right the way through this and tick stuff off as you do it in the exam to make sure that you don't miss anything out. Now, going back to the students' results, we've got this concentration time graph, which uses the concentration of bromine. Now, looking at the shape of the graph, if you've revised your graph shapes for concentration time, you will know that if I go down to my analysis just here, that the graph shape tells us that it's 0 order with respect to the bromine. Now, what you're not allowed to say here, which apparently a lot of people do, and I did actually notice this when I've set this to some of my own students historically, people often say because of the shape of the graph, because we do learn, quite rightly, that the shape of this graph, as you can see here, does represent that of a 0 order reactant. Well, you do need to describe the graph in a bit more detail and link it to what you know about a 0 order concentration reactant. So what we need to say is we've got a linear, or you can say constant, negative gradient. So you've got to describe the graph in a bit of a way that links it up to the fact that we're saying it's 0 order. And we also need to do the same thing for student 2's results here, as once again we have another graph. However, this time it's a rate concentration. So what we've got at the bottom here is the propanone, and you can see that we've got this nice straight line graph just here, and it does start down here at the origin. Now look at my description for this one. We're saying it's first order, and once again, to be honest, I'm saying that based on the shape of the graph, because that's another one of the shapes that we are expected to be aware of. That does come up very often in the multi-choice questions, I'd like to say as well. Now here, what we've got as the descriptor is that rate is directly proportional to the concentration of the propanone. So we can see here is this nice, clear, straight diagonal line through here. And so there's a directly proportional relationship between those 2 features, the rate of the reaction and also the propanone concentration. You could have said that it's a straight line through 0, 0, so through the origin on the graph, but I think this proportionality feature just here is something that I would expect people to recall more. Now, student 3's data isn't a graph. What we've got here are 2 experiments, so repeating the same experiment twice, and as you can see here, the concentration of the HCl represented as H plus here because it's a catalyst in this, and it's that acidic feature that's the catalyst. This concentration has been doubled, and the other concentrations have been held constant. And we can see here the rate of reaction has changed by a doubling as well. Notice, just before we carry on, this. Just here, sneakily inside the table of results, the initial rate here is not just 1.25 or 2.50, it's actually 1.25 times 10 to the power of -5. And this often happens for these rates tables just here, and occasionally, although it hasn't happened in this particular circumstance, it does happen on the rate axes of a graph. So watch out for those standard forms. Now, as a result of that analysis of the data table, we can say that it is first order with respect to the H plus ion, and that's because from experiment 1 to experiment 2, the concentration of the H plus ion doubles and the rate doubles. That allows me to conclude here that I don't need to put the bromine in the rate equation and that the other 2 concentrations are first order, so I've written my rate equation just here. You can include the Br2 concentration to the power of 0, but I choose not to do that, and I think it confuses things when it comes to the units later. I then need to rearrange because if I go back to the instructions of the question, I have been told here to determine the rate constant. And so I rearrange to make K the subject just here, which is rate divided by those concentrations. And what I'm going to use here are concentrations from student 3's data, and I'm going to use this top line just here. So I'm going to use those to calculate this. and that gives me a value of 3.91 times 10 to the power of -5, and I always include the units here, especially if it's a level of response question, because I find that this often does get included in the mark schemes, even though they've not asked you to state the units. Thank you so much for watching this tutorial. I really hope it has made a difference, but before you go, I do need some help. Please leave this video a like before you go, because it really does help support my channel and let YouTube know I still exist. There's loads of good stuff around the screen now, and links to my other video content in the description down below, so make sure you check that out before you head off. Until next time though everybody, happy revising.